The implementation is done using OpenCV with extra modules installed on Python in a Windows-based environment. A webcam is also used to capture live frames. What we use for training in the form of database of negatives is the AT&T Laboratories database of faces, also known as ORL database. For the database of positives, we captured images using camera. These images were then cropped and resized and fed into the training set. I'll give a brief code walkthrough of the entire Python code that is written for face recognition. So as you can see, we first define a function, getImages, that takes the absolute path to the image database as the input argument and returns a tuple of two lists, one containing the detected faces and the other containing the corresponding label for that face. For example, if the ith index in the list of faces represents the fifth individual in the database, then the corresponding location in the list of labels has a value equal to 5. We are appending all the absolute path names of the database images in the local path. We are not appending images with the .wink extension, as these images are used to test the accuracy of the recognizer later. We first declare two lists, pictures and labels. In the list pictures, we append the region of interest containing the face, and in the list labels, we append the corresponding label for that face. We then loop around each image to detect the face in it and update our two lists. We load the current image in a 2D NumPy array image. We use the image module from the pillow to read the images in grayscale format and convert them into NumPy arrays, which are compatible with OpenCV. In the prepareImage function, we use the image name to extract the individual number. This number will be a label for that face. We then use the detectMultiscale function to detect faces in the image. The detectMultiscale function returns a list of faces. These faces and their corresponding labels are returned back to the original function. For each face, the prepareImage function returns a rectangle in the format of top left x pixel value, top left y pixel value, width of the rectangle, and height of a rectangle. Next, we slice the region of interest from the picture and append it to the list pictures and the corresponding label to the list labels. Once we are done with this loop, we return the two lists in the form of a tuple. We pass the getImages function with the path of the database directory. This path has to be an absolute path. This function returns the features and the labels which is used to train the face recognizer in the next step. Perform the training using the faceRecognizer.train function. It requires two arguments, the features, which in this case are the images of the faces, and the corresponding labels assigned to these faces, which in this case are the individual number that we extracted from the image names. The steps to recognize face involves capturing the image, then detecting the face, cropping and resizing around the face, and projecting across all eigenvectors. Then finding the face class that minimizes the Euclidean distance, and returning the label from the face class and also the Euclidean distance. The Euclidean distance is used as a confidence level here. We then test the results of the recognizer by using the images with the .wink extension, which we had not used earlier. As done in the getImages function, we append all the image names with the .wink extension in the face database list. Then for each image in the list, we read it in the grayscale format and detect faces in it. Once we have the ROI containing the faces, we pass the ROI to the faceRecognizer.predict function, which will assign it a label, and it will also tell us how confident it is about the recognition. The label is an integer that is one of the individual numbers we had assigned to the faces earlier. This label is stored in the predicted subject. The more the value of the confidence variable is, the less the recognizer has confidence in the recognition. The confidence value of 0 is a perfect recognition. We then check if the recognition was correct by comparing the predicted label and the actual label. The label actual subject is extracted using the OS module and the string operations from the name of the image. We also display the confidence score for each recognition as shown in the output below. We print the min, max, and mean values of the confidence at the end of the execution. From the image below, we can see that our face recognizer was able to recognize all the images correctly. The face databases used in this project were the AT&T face database, also referred to as ORL database of faces, which contains 10 different images of each of the 40 distinct subjects. For some subjects, the images are taken at different times, varying the lighting, facial expressions, and facial details. All the images are taken up against a dark, homogeneous background with the subjects in an upright frontal position. We also use the Yale Face Database A, also known as Yale Faces. The Yale Face Database A is a more appropriate dataset for initial experiments because the recognition problem is harder here. The database consists of 15 people, 14 male, 1 female, each with 11 grayscale images, size 320 into 243 pixels. There are changes in the light conditions, facial expressions, and glasses. The results of the experiments were as follows. For the eigenface recognizer, we got a mean confidence value of 41.70, from a max confidence value of 48.89, and a min confidence value of 32.12. For data sets 2 and 3, we can see the values as follows. When the confidence is plotted for frames captured in real time, it gives us the following graph, where the confidence represents the distance from a known face class. By setting some threshold value, we can obtain a binary determination, yes or no, of which frames contain the frontal view of my face and which ones don't. We can also tag an individual by matching the face capture to the subject stored in the database. So we can conclude that we have successfully implemented the OpenCV's Eigen Face Recognizer, and we have compared using different training models and a number of training images for different poses and lighting variations, the recognizer that we implemented. We've also successfully compared Eigen faces, Fisher faces, and local binary patterns, histograms techniques. There's a lot of future work going on in this domain, as we have discussed earlier, where there are several algorithms that make use of artificial neural networks and other techniques like support vector machines to give a better face recognizer algorithm that minimizes the error rate. We will now run the program. So program is now currently loading the faces for training. It runs through all the faces in the Yale face database A, collects the faces and projects them into the Eigen vector space. It ignores all the images with the dot wink extension, as you can see. It will later use these images for for face recognition. These are the images of subjects numbered from 1 to 15. As you can see, it provides us the confidence value for each and every image, and all the images are recognized correctly by the algorithm. The real-time algorithm is as follows. It again runs the face recognition, and then it detects my face correctly. The confidence values for each of the faces detected can be seen in the command console besides me. Thank you.